Good afternoon, good evening, ladies and gentlemen. Welcome to another series of online lessons. And we are in linear algebra today. We've had a good run in linear algebra. We've looked at previously on how to find the inverse of a matrix. So we looked at how to use row operations to find the inverse. Then we also looked at how to use the cofactor method to find the inverse of a matrix. Now, related to the inverse of a matrix, today we will be looking at how to use row and column operations to find the determinant of a matrix. Okay, now for you to be able to do that, there are some rules that you should follow. Okay, so the first rule is that when you introduce a constant to a row that you're transforming or a column that you're transforming, so for instance, row I is equals to A row I plus B row J. Okay, so row I. So we have introduced a constant to the row that we are applying, we are transforming. So what we should do is that on the transformed matrix, we should multiply by the inverse of that constant that we have introduced. So same applies if we introduce a constant to the column that we are transforming, say column I is equals to maybe A column I plus B column J. So immediately we introduce a constant to the column that we are transforming, we multiply by the inverse of that constant to the matrix we have transformed. Let's look at an example. So suppose we have a matrix 1, 1, 1, 0, 1, 1, 2, 1, 2. Okay, and maybe we want to apply the column operations, column 3, or let's say column 2. Let me just pick the column 2 changes to 2 column 2 plus 3 column 1. Okay, so suppose we have that. So we have introduced a 2 on the column that we are transforming, so we should multiply by 1 over 2 to the matrix that will be transformed here. So column 2, 2 times column 2, so 2 times 2, that will be 2 plus so this is column 2 that is changing, so column 1 remains the same, 1, 0, 2. Column 2 is the one that is changing, so column 2, 2 column 2, 2 times column 2, that will be 2, plus column 1, that will be 5. 2 times 1, that will be 1, that will be 2, plus 0, that will be 2. Then 2 times 1, that will be 2, plus 6. So 2 plus 6, that will be 8. Then column 3 remains the same. That is 1, 1, 2. Okay. So same applies if we're applying a row operation. Let's say row 1 changes to 3 row 1 minus, well, let's try negative 3 row 1 plus row 2. Okay, plus 2 row 2. So suppose we have this row operation, negative 3 row 1 plus 2 row 2. So again, since we have introduced a constant negative 1 over negative 3 on the row that we are transforming, so we are going to multiply by the inverse of that, so that will be 1 over negative 3 times the new matrix. So that will be negative 3 row 1, that will be negative 3, plus 2 times row 2, that will be 0, that will be negative 3. And negative 3 times that will be negative 3, plus 2, that will be negative 1. Again, that will be negative 1. Then whatever is here remains the same, 0, 1, 1. 2, 1, 2. Okay, so that is basically the first rule. If we introduce a constant to the column that we are transforming, we should multiply the matrix by the inverse of that constant. So that is rule number 1. Now we go to rule number 2. Rule number 2, if you're applying column operations, then you swap columns. Okay, so if you're applying column operations, then you swap column I and column J. You need to multiply the matrix by a negative. Okay, so for instance, so this is only happening for columns. For row operations, you can swap. There is no change that happens. But for column operations, once you swap the columns, you need to multiply the final matrix by a negative. So for instance, if we have the following matrix, let's say 1, 1, 1, 2, 1, 1, 3, 1, 1, something like that, then we decide to swap column 2 and column 1. Okay, so immediately that swap happens, we multiply by negative. So this is negative 1 times the new matrix. So that is column 1 swaps with column 2. So this comes here. So that will be 2, 1, 1. Then comes here 1, 1, 1. Then 3, 1, 1. So we multiply by negative whenever we swap columns. Either column 2 swaps with column 1 or column 1 swaps with column 2. So that is what happens. All right, the last rule, we're calling rule 3. If there are any common terms in the entire row or in the entire column, we can factor out those terms. So for instance, if we have AB, then A, then maybe we have 2B, 3, 4, then maybe we have 3, 12, and 9. Okay, so suppose we have that. Maybe here, let me put 3 here. So suppose we have that. So, and we see that there are common terms in a row or in a column. So here we see that there are common terms in a row, which is A. So we can simply factor out the A, and what will remain here is B, 3, A, and everything else, 2, 2B, 3, 4, and 3, 12, 9. Okay, so we can do that. So sorry, here we're going to remain with 1. So when we factor out A, here we have B, here we have 3, then there we are going to have 1, then 2B, 3, 4, then 3, 12, and 9. So again, we see that there are common terms here. So we see that there is a common 3 here, 3 here, and 3 in 12. So we can also factor out that. So we have A, we also factor out times, we say times 3. So when we factor out 3 here, this will remain as it is. That is B, 2B, and 3. Then here we're going to have 1. When we factor out 3, here we're going to have 1. And here we're going to have 4 when we factor out. Then here we're going to have 1, 4, 9. Okay, so that is basically what factoring out is. So if we have a similar term in the entire row or in the entire column, we can factor out that term and we multiply it outside. So basically those are the rules that we're going to be applying. Now let's look at an example where we will apply these rules. All right, so we have been asked to evaluate this. So whenever you see a matrix with straight line brackets like that, then basically they're asking you to evaluate the determinant. So for starters, we see that we can factor out 2 in the column here. We see that 2 is common here. So we can factor out, this becomes 2 outside. Then we have 1. Here we're going to remain with 2. and here we're going to remain with 4. Then here we have 1, 1, 3, 1, 1, 0. Okay, so now what you want to do before you start applying row operations is that you can either make these to be zeros or those two to be zeros. So whichever one will be easier for you, either to use these to be zeros or those to be zeros. So if you choose to make these to be zeros, then you'll be using column operations. If you choose to make those zeros, you choose to be making row operations. And this method helps you to find determinants even for bigger matrices. Okay, so we have that. So we can choose to make a 0 here. How can we make a 0 here? We can say row 2 changes to row 2 minus 2 row 1. Okay, so there is a 2 that we have here, so we maintain it 2. Then row 1 is maintained 1 1 1. So since this 2 is not on the matrix that we have on the row that we are transforming, so it does not affect the matrix. So we just go on. So 2 minus 2, that will be 0. 3 minus 2, that will be 1. 1 minus negative 2, that will be negative 1. So we can also choose to make a 0 here by saying we put an arrow in between here, then we say row 3 changes to row 3 minus 4 row 1. So we say this will be 0. Row 3, that is 1, minus 4, that will be negative 3. Row 3, that is 0 minus 0 minus 4, that is negative 4. Okay, so we have something like that. So immediately we have that. Whatever number is here, we can introduce the cofactor method. So we have 2 times whatever number is here, we put it there. So in this case, times 1. Then we write the cofactor, that is 1, negative 1, negative 3, negative 4. Okay, then here we want to make a 0 here. How can we make a 0 there? So we can say row 3 changes to, okay, let me just show you how we would if we said 3 row 1 plus row 3, or if I want, I can make a 0 here by using column operations. I would simply say column I want a 0 here. I would say column 2 changes to column 2 plus column 1. So this becomes, we have a 2 times 1 here, which is just 2. So I can just write here 2 times 1, which is 2. So column 1 remains unchanged, which is 1, negative 3. Then we have 1 plus that will be 0. This plus that will be negative 7. Then when we multiply, so this times that will be, there's a 2 out here. So we say 2 times this times that will be negative 7. This times that will be 0. So it will just be negative 14 as your determinant. Okay, so that is how you use row operations and column operations. And observe that we're using both row operations and column operations to find the determinant. So that is basically how you do that. Let me just do maybe one more example. All right, so we have this example. You're asked to evaluate this again. So maybe again, we want to make a 0 here or 0 there. So we can make a 0 here and here, or we can choose to make a 0 there and there. So whichever method you choose for you. So if you choose there, then you're using column operations. Choose there, then you're using row operations. All right, so let's decide to make a 0 here. To make a 0 here, we can say row 2 changes to 2 times row 2 minus row 1. So remember what we said, if we introduce a constant to the row we are transforming, we need to multiply by the inverse of the constant to the matrix that will be transformed. So we've introduced a 2 to the row we are transforming. So we multiply by 1 over 2, which is the inverse. Then we now transform. So row 1 remains intact, 2, 1, 2. Then row 2 changes. So 2 times 1, that will be 2 minus 2, that will be 0. 2 times 1, that will be 2 minus 1, that will be 1. 2 times 1 minus 2, that will be 0. Okay, so we can do the same for row 3. We can say row 3 changes to, we said 2 times row 3 minus 3 times row 1. So we are only allowed to use row 1. So again, we've introduced a 2 to the row that we are transforming. So again, we say times, again, times 1 over the constant we've introduced. So now then we apply the column operation. So that will be 2 times 3, so that will be 0 here. 2 times 4, that will be 8 minus 3, 8 minus 2, that will be 5. 2 times 1, that will be 2 minus 6, that will be negative 4. Okay, so we have our zeros there. So we're going to have 1 over 2 times 1 over 2. Then we have our matrix, which is 2, 0, 0, 1, 1, 5, and 2, 0, negative 4. So now here what we want to do is we can introduce the cofactor method now. So since we have zeros here, so the cofactors of this will be zeros. So what we'll just concentrate on is the cofactor of 2, which will give us, so we can factor out the 2 here. It will be 1 over 2 times this other 1 over 2, then times whatever number is there. In this case is 2, so times 2, then the cofactor of 2, which is 1, 0, 5, negative 4. Okay, then from here we can simplify this. So this will just be 1 over 2 out here. Then now we here we are going to have since we already have a 0 here, we can choose to make a 0 here by saying, okay, let me just write it first of all. So this and that will cancel out, will remain with 1 over 2. Then we have 1, 5, 0, negative 4. So I can choose to make a 0 here, or I can choose to make a 0 there. So whichever method I choose. So if I choose to make a 0 there, I can say row 2 is equals to 5 row 1 minus row. Okay, so again, I have introduced a negative to the row I am applying row operations on. So meaning that I need to multiply by 1 over negative 1. Then there is this times 1 over 2, which is this part, then times the matrix that we have here. So you should be well aware of this. Immediately introduce a constant to the row you're transforming, you should be aware of that. So now row 2 changes to, so row 1 remains unchanged, that is 1, 0. Then row 2 changes to 5 times row 1, that would be 5 minus 0, that would be 5 minus 5, that would be 0. Then 5 times 5 times 0, that would be 0, minus negative 4, that would be positive 4. Okay, so minus, that would be positive 4. So now what we have out here is negative 1. 1 into that, that would be negative 1 times 1/2 times, here the determinant is only 4. So when we simplify everything, we're going to have negative 2 as your final answer. So that is basically what you're supposed to do. So I'm just lengthening the process so that you understand everything that we are doing here. So you're going to try out the following. All right, so you will evaluate these determinants. Then from there, we see how we progress, because this is just the introduction. We'll be using these in more complicated problems. So make sure you understand and you're able to do your work by yourself. Have a good evening. So this is about it for today.